Okay, so first lesson we looked at what you might call the algebra of solving linear equations. But like I said in the last lesson, linear equations represent equations of straight lines. So now what we're going to look at is how best to represent these straight lines. And that is on something which you would have seen before, which is an XY graph, or Cartesian graph is another name for it. So let's just talk a little bit more about this equation of the line. Normally, you write equations of the line like this: y equals mx plus c. So this is the equation of the line. Now there's different ways of writing it, but this I find is the most convenient way.
Hi.
Do you need to say something to them? Or?
Yes.
Yeah, okay.
Everybody here?
Right, back to full screen. Right, so the reason we write it like this is because number one, it's easier to draw, and number two, the m and the c have special names. Does anybody know the general name for this m and this c? They're called something special.
Slope.
Slope is the specific name, yeah, but the more general name for both of them. Variable? Oh, no. Whoops, sorry. Not too far off with constant. See, I like this now. I just wrote down two lessons or two letters. You're already making reasonable guesses, but if I put down the next one, oh yeah, very good. That's it. Coefficients. So that's the name given to this m and this c here. They're called coefficients. And Sarah, you said variables? That's the name given to, yep, the x and the y are called variables, or more simple, a simpler word that sometimes people use is unknowns or variables. Okay. The m and the c are important because they tell us something about the shape of the line. Now somebody gave me the word for the m earlier. What was that? Slope, yeah. Now what about the c? Very good, intercept. And perhaps to be more particular, the y-intercept, yeah. But for the moment, I think intercept will do fine. So that's the name of the m and the c. But there's another name for the m, which I wrote down in the book, which you'll see later. Does anybody know another word for slope? And it's the word that's used in the UK, yeah? Gradient. Gradient, yeah. Did you say derivative? Or no? Gradient is another name for slope. In Ireland, we use slope. In the UK, we use gradient. In the exam, well, I suppose it could be anything really. But slope is what I would probably say in class. But you need to remember that gradient is also another word for it. Okay. Now, sorry, I'll go back up a little bit. Whoops. This here is called an XY graph, or just a graph, or Cartesian graph. What's this piece called? Does anybody know? The x-axis. And then this one here is called the y-axis. And this is called Cartesian, and Cartesian isn't really a word in English so much. Like, I mean, it is, but it's called Cartesian because it's named after the person who discovered this graph. Okay, so you don't have to really worry about what Cartesian means because it doesn't mean anything because it's a name. Okay, and most people actually call it an XY graph anyways. Now, I'm sure you remember this, but just as a little bit of a revision, you can put points on these graphs, points that look like this, x, y. For example, 2, 6. So what that just means is you go out 2 on the x-axis, and then you go up 6. 1, 2, 3, 4, 5, 6. And of course, if I was doing this neatly and properly, you would have graph paper, and you would have the numbers running along the axis. Okay? And what if you do if it's negative? Well, it's the other way. So if I have -2, it means I go to the left, and if I have -6, that means I go down instead. Does anybody know the name of this? Well, I gave you one already. It's called a point, but there's another name for it as well. Yeah, coordinates as well. There's 3 ways to spell coordinates. That's one of the ways, yeah. Have you seen it spelled with 1 O?
It's CO and then slash.
Yeah, that's the second way. And does anybody know the third way? It would impress me so much if anybody knew the third way to spell coordinates. That's the second way, and the third way is to spell it like this. With 2 little dots there, okay? But this way hasn't really been used for about 100 years, so there's really only 2 common ways to use it. A lot of people don't bother using the hyphen anymore, but anyways, I'll put the hyphen in because it'll help to pronounce it. It's coordinates, okay, so separate out the O's. So point or coordinates is the name for this, and like I said, 2, 6, come out 2, go up 6. But I told you earlier that this here represents a straight line, and you can say something about the line by knowing what the M and the C is. The C represents the intercept, which, does anybody know what that means on the graph here? Yeah, what's it mean?
The 0 point.
Yeah, 0 point.
Where the crosses.
Yeah, where it starts, where it crosses, basically where it starts on this y-axis here. So I'll give you like a rough example. If I have y equals 3x plus 2, I know that my line will start at 2 on the y-axis, so that's here. So I know that it goes through that point at least. But can anybody tell me the meaning of the slope here? So if this number is very big, what does that mean? Does anybody know? Yeah, what's the name of this? It's very steep, yeah. So if this number is big, it means the line looks like that. If it's small, like 1, for example, the line would not be so high. If it's 0, what do you think if there's a 0 here? Any ideas? It just goes straight across, yeah. And then finally, if it's negative here, it goes down, yeah. Now we'll do an example properly in a moment, but it's good to have a rough idea in your head, a rough picture of what the line should look like. So 2 here means I start at 2, and then a positive 3 means it's quite steep, it goes up quite fast. Okay? Please take down this vocabulary now, it'll be very important. Let me just pause this for a second. Lorraine? Yes, hang on a second, sorry. Yeah?
So the intercept is always in the y-axis.
Always, that number at the end called the intercept always represents where it is on the y-axis. Although we will look at something called the x-intercept, but that will not be related to this C piece at the end, okay? So this C piece at the end always refers to the y-intercept. But there is a term called the x-intercept.
The 3 behind the x, so we go to the 3 and the x.
Say again?
The 3 behind the x.
The tree behind the slope, yeah, what about it?
So we put it in the x.
I'm not sure what you mean. Do you mean that this tree should be on the x, or? Yeah, the slope is always on the x and it's always in front of the x, and the intercept is always at the back and it always has no x on it. Is that what you're looking for? You seem unhappy with that. It is okay if you want to write it the other way around, like 2 plus 3x. This is still the slope and this is still the intercept, but it's not so common to write it backwards like that, although there's nothing wrong with it. So the slope is always the number in front of the x, not necessarily the first number. Is that okay? I don't know. You don't seem too happy with that. Is it okay? It's okay? All right. So, what do we do if, like here, Hassan, it's not written the way we expected? Well, let's look at an example like that. So, as my first example, I tell you that this here, 6x plus 7y plus 3 equals 0 is an equation of a line. And you might say, well, it's not written like the way we're familiar with. And it's always good to rewrite it the way you're familiar with it, because then you can interpret what the slope and the intercept is. As it stands now, it's a little bit difficult, although not impossible, to see what the slope and the intercept is. It's a good habit to rewrite these. So you see that you want to keep the y on the left. So you're happy to keep this on the left. That's fine. You should take the other two pieces to the right. Now you see that you're halfway done, or more than halfway done. There's only one small complication that remains. What's the remaining problem? Yeah, well, not the x actually, the y. What's the problem with the y?
7.
The 7 is on it, and you don't want the 7 on it. So what should you do?
Take the 7 to the other side.
And how does it come to the other side? By dividing or by multiplying. So in other words, you don't do a minus 7 at the end. Instead, you get this. Question, yeah?
Shouldn't it 3D minus?
Darn tootin' it should be. Yeah, thanks. Minus 3 when it comes over. So then that changes that one there. Okay, and that's minus 6 over 7. Now you can see, oops, you can see what the m is, and you can see what the c is. In both cases they're negative. So if I was to draw a very, very rough sketch of this line, okay, well, yeah, definitely going down, and because it's negative 3 over 7, it starts under, and because it's negative 6 over 7, it's sloping down. So this line here would look roughly something like that. Okay. Sometimes in the exam they want a rough sketch, and sometimes they want a more exact sketch, exact drawing. At the moment we're just doing rough drawings, but in a minute or two we'll do a little neater, more exact one. Okay? So I'll go on to another example now, just give you a moment to write that. Okay, so next example now. Example. I give you this line, y equals 4x plus 2, and I give you this point, minus 7, minus 25. Very rough sketch. Positive and positive, so it looks something like this. Roughly. So my question is this point here, is it actually on this line or is it off it? You know, minus 7, minus 25 will be somewhere down here. It's possible that it's on the line, and it's also possible that it's not on the line. And I would like to check if it's on the line or not. Now this is kind of a basic enough skill, but it's something that people forget, and it's something that comes in handy for more difficult problems. So, do you know how I should check this? Yeah?
It won't be on the same line.
Yeah, but how can I check? How can I know for certain if it is or not, yeah?
Minus 7.
That's it, put minus 7 in for x and minus 25 in for y. And if it's true, it's on it, and if it's not true, it's not on it. So I get here minus 25 equals 4 times minus 7 plus 2. So I get minus 25 equals minus 28 plus 2. So minus 25 equals, what's that, minus 26, isn't it? So it's looking false here.
Yeah.
Unless I made, that's right, did I make any mistakes here? Minus 25 there, minus 7 there, 1428 plus the 2, yeah, minus 26. So it's false. So it's off the line. It's not on the line, it's off the line. Yeah?
Just, excuse me, the slope is positive, so why did you put in the other one?
Here is 2. So are you happy with firstly this point being 2? And the slope is 4, which means it's going up like that. And if it was negative, it'd be going down like that. Okay, so if it helps, this is what a positive slope looks like, and that's what a negative slope looks like. Yeah, is okay?
So the 4 is the other side of the Cartesian.
Like what number does this represent on the graph? Yes, we haven't done that yet. We'll do that in a moment. I see what you mean. Like, is it a number on the axis? It's not actually. It just tells me how steep the line is. But we'll interpret the 4 more precisely in a moment. Yeah, actually, we'll do that one next now. Okay. Let's take... Yeah, okay, let's take this one as an example. So can anybody give me the interpretation of the slope, the gradient 5/8? Could anybody explain to me what it means? So if I said the slope is 5/8, what does that mean? Any ideas? Yeah, go ahead. It goes up 5 and yeah, right 8. So in other words, if you have a slope of 5/8, what that means is on your line, every time you travel 8 units to the right, you will travel up 5 units. So in the previous one, what was our slope? 4x was it, wasn't it? What was it? 4x plus 2. Now, there's no denominator here, but really there is. What's the denominator here? 1. So that means for this line, every 1 unit I go out, I go up 4 units.
Yeah.
That's why if this is negative, I go down. Because if this was minus 4, it would mean for every 1 unit I go out to the right, I go down 4 units. And that's why it slopes down like that. Right, let me do a proper